QSC Designer software contains several components that can be added to your design and then configured to provide control functionality. For programmers that are relatively new to the platform, or for more complicated programming involving a large number of control components, there are some troubleshooting tools available in QSC, as well as a few important control concepts a programmer needs to understand. Let's start with a simple example. In this schematic, we have a custom controls component configured to provide two trigger buttons to drive the decrease and increase input control pins on a value stepper component. If we press the trigger 1 and trigger 2 buttons, we would expect the value stepper to decrease or increase its value. As you can see, this does not appear to function correctly. There is a very helpful tool available in Designer to help diagnose these types of issues. If we go to the Tools menu and select View Component Control Info, we will now see a pop-up window which I am going to dock at the top left of Designer. This window will provide a list of available controls and, more importantly, their control types for any component we select in the schematic. These control types typically consist of Boolean, float, integer, string, or trigger, and let us know what type of control values the component will expect to receive on a control input pin, as well as the type of control value the component will provide on an output pin. While the control components in Designer are quite forgiving when mixing and matching various control types from one component to another, you can sometimes run into issues when a control component is receiving a mismatch control type. If I select the value stepper component, we see that the decrease and increase controls are Booleans, but we are feeding these input pins with triggers. This mismatch in control type is the source of our issue here. If we look at this corrected example where we change the custom controls button type to momentary, which will produce a Boolean control type value, we see that the value stepper then functions correctly. In the next example, we have a text controller scripting component that provides a toggle button control that we would like to use with the Surgex Access plugin to control the electrical power of our AV system. If we press the power toggle button multiple times, we notice that the power outlet state does not follow the state of the toggle button, and we have to press the button twice for power on and twice again for power off. To troubleshoot this issue, we can check the control type of the Surgex plugin in the Component Controls window to find that the power outlet control is a trigger. This trigger input will work with a low to high transition from our power toggle button's Boolean value, but not from a high to low transition, which is why we have to press the toggle button twice. To correct this issue, we can use a control function component configured as a logic 1 of N function. We will need to route both the output of our power toggle and the Surgex outlet's state output into the inputs of our control function. Now the Surgex plugin will receive a low to high transition to activate the trigger when the power toggle goes high, and then receive another low to high transition when the power toggle goes low to turn off the power. Moving on to another troubleshooting example, in this design, we are attempting to perform a value sum of some integer knobs and the value output from a selector component. If I change the integer knob values, you can see that the value sum is adding these values. But the selector's value output is not included in the overall sum. To troubleshoot this issue, we can use a couple of tools. We can use our Component Controls window in Designer to determine the selector's value control type, which is a string. We can also use another tool such as the Control Signal Monitor script to monitor and track control value changes in our design. This helpful script and many others are available from the QSC Community's website. If you are unfamiliar with the QSC Community's website, this site is a location for QSC programmers to ask questions and receive answers for QSYS-related topics, as well as download example designs and control programming such as this control signal monitor script we will be using to help troubleshoot this issue. If we take a closer look at the selector's value, we see that the string value is changing, but the actual integer value remains 0. For us to correct this issue, we will need to find a component that can interpret the string and provide an integer control value. To do this, we can add a custom control configured as an integer knob. These changes are now being converted by the custom control's integer knob, and the value sum is now providing us with an accurate sum of the control values. To assist with troubleshooting plugins and scripts, the left pane of Designer includes a section called Inspector that provides information to help locate and identify scripting and plugin issues. In this example, I am currently connected to a core, and if we navigate to the Inspector pane in Designer, we see the Scripts and Plugins sections that include a list of the scripting components as well as all of the plugins included in our design. Paging through this list, we can quickly scan all of the scripts and plugins in the design to identify which ones may be causing an issue. This design includes a script named Inspector Demo that I have added to help illustrate some of the diagnostic information provided by the inspector. If we open up this demo scripts section in Inspector, we can monitor various aspects of this script while it is running. Starting at the top, we see a load percentage my script is consuming. This load percentage is based on the processing time required for my script to run versus the total processing time Designer allocates for a script or a plugin to finish processing. If I then set my demo script to perform some very processor-intensive tasks, you will see that the amount of processing time consumed by this one script will increase. This increase in processing time is also reflected by the control and Lua compute usage in the core's status component. If you have a large number of scripts or plugins, or just a single processing-intensive one, this processing time percentage can help identify where your design may have an issue. Next, we have the memory consumption that displays how much RAM my script is consuming. This can be helpful identifying issues such as memory leaks where an ever-increasing amount of RAM is being consumed. With my demo script, I created a trigger to start a memory leak by storing more and more data to RAM as shown in Inspector. This increasing RAM consumption is also shown in the memory usage meter in the core status component. If this were left running, this would eventually cause serious stability issues for my design, as the core will eventually run out of RAM. If we look in Inspector below the memory usage, we have errors, which will display if there have been any processing errors while running a script or a plugin. If I use my demo script to execute some poorly written code that causes an error, not only will we see this listed below memory, but we will also see a red indicator beside the name of our script to help us locate if a script or plugin is having an issue. In addition, the inspector displays the verification status of scripts and plugins. As an example, a plugin such as the Surgex plugin in this design has been verified by Designer and can be trusted to be an unaltered official version of the plugin. If a programmer was to download a plugin from Asset Manager and then crack open and make any modifications, this verification process would fail and the status in Inspector would show as verification failed. If we look at my demo script status, this shows as unverified, which indicates that the script has not gone through the verification process, which is perfectly normal for user-generated scripts. As you can see, Inspector can be very helpful when locating and diagnosing issues, but this can also be helpful when writing your own scripts and plugins to check for memory leaks or excessive processor consumption to avoid these issues while your code is still in development.